Okay, so for this problem, we are given a spider's web, and this is something that have, so this spider web, we'll define it with, it have n sectors, and each of these sectors have some bridges. That's it. So that's the description of the web. It have n sectors, and each of these sectors have some bridges, and each bridge, for each side of each bridge, it has the same distance from the center of this web. Okay, so this is a bridge, this is another bridge, this is another bridge, and so on. And the cell, and in this problem, a cell is the area between any two consecutive bridges. Okay, so this is a cell, 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 and so on. Okay, and also an unstable cell is a cell which have um, not equal number of bridges on its both sides. Okay, so this cell, this cell number 3 here, which is colored in red, have 3 bridges on the right side. So it's have 3 bridges touching it on the right side, which is 1, 2, 3. And on the left side, there are 4 bridges, 1, 2, 3, 4. So this is unstable, okay? But let's look at some green cell. This, for example, it has, at the right part, it has 1 bridge here, one bridge touching it, and the left part, it has 1 bridge touching it. So this is stable, okay? So unstable cells have not equal, so the number of right bridges and number of left bridges touching this cell are not equal. And we want to count the number of unstable cells in that spider's web. Okay. Did you get the problem? Any question? Okay. Any ideas
What are
now?
the what are cells? Can you just tell it
What
once
are
again?
cells?
Yeah,
You're
just
saying what
yeah,
are cells?
yeah. What are cells? Can you just tell it once again?
Okay. Cell is the area between two consecutive bridges. That's it in one sector. So
Oh,
take any sector and take any two consecutive bridges. This bridge, there is a cell. Okay.
okay, got it.
Okay. So do you have any ideas for how to solve this problem? It's easier than it looks. And actually, when you look at the constraints, they are too small. I don't know why, but it's too small. It's 1000. So we have at most 10 power 3 sectors. And also at most, oh no, they are not small. So we have at most 10 power 3 sectors, but we have at most 10 power 5 cells. Okay, so it's guaranteed that the total number of bridges doesn't exceed 10 power 5. So the number of cells also should be around 10 power 5. Any ideas? Okay, let's look on how to know a cell is stable or not. So we said before that a cell would be stable if the number of right bridges touching it equals to the number of left bridges touching it. And actually the given input makes it easier for us because the input is given us for each sector the bridges in an increasing order of the distance from the center. Okay, so here the first sector, sector number 1, we have bridge at a distance of 1 from the center, another bridge at distance 6, another bridge at distance 7. Let's look at sector number 1 here. So 167. So sector number 1, we're given a bridge at distance 1, which is this small one, and another bridge at distance 6, here is it, and another bridge at distance 7, here is it. Okay, so we will loop through every cells to check. Okay, so for every sector we will loop through every cells, and every cell is bounded by two bridges. So we'll start from I equals to 2 until I equals to k, and then check. So we are
Ahmad,
giving,
what's the color coding over there? So that green and pink, what does it signify? Whether it's
okay,
stable or
so the green is a stable cell and red is unstable cell. Okay, so here red, so here let's look at this cell at sector number 3. It's colored red, so it's unstable. And we'll see why it's unstable, because the number of left bridges touching it is 4, and the number of right bridges touching it is 3. So they are not equal, so it's unstable. But let's,
if you see that sector one, the first cell is pink, right? But it is stable in both the sides. It is touching three bridges, right?
no, actually, in the right side, it's touching only two bridges. There are no third one, right? So one, two. And the left, there are one, two, three. Did you get it?
Oh, okay, okay, yeah.
Okay. Uh, so here, as I said, we're going to loop over every cell and then see how could we check that. So let's see. So for every cell, so we are given n, which is the number of sectors, and then we are given n lines, and for each sector we are given k, which is the number of bridges. Okay. So let's say, okay, so we are given k, which is the number of bridges. To loop for every cell, we'll start from I equals to 2, not 1. So it's 1 based index. So start from I equals to 2 until I equals to k. And then check for every bridge. So then check bridge I with bridge I minus 1. So that's a cell. Okay. So a cell is is bounded by bridge I and bridge I minus 1 from every I from 2 to k. Okay. So how to check if it's stable or not? Any ideas? Okay, let's look at this. Let's look at numbers instead of the drawing. So here, if we look at 3 and 5, we know that a cell, so to check for the stability of the cell, we want to check only the bridges that are within, so only the bridges that are within a distance between these two bridges. Okay, so here we have one cell bounded by bridges from 3 to 5. Okay, where is it? 2, 3 to 5. Actually, this is a good cell. I want to check another cell. Let's check 2 and 9. Okay, so 2 and 9 is a cell starting from 2, ending at 9. So it's not sorted. Okay, so to see if this is stable or not, we will check the previous sector and the sector after it, and then see, and then count the number of bridges that are within 2 and 9 in these two sectors, right? Because and then if I found, for example, three bridges in that previous vector between 9 and 2, and then found two two bridges between 9 and 2, then it will be unstable. Okay, so let's count the number of bridges between 9 and 2, the after cell. It will be only 8. So here, 1 at the right side, and for the left side, we have 6 and 7. So this is not okay. Let's search for an okay bridge, for an okay cell. So here at 5. So let's check 5 and 9, this cell. So let's see the previous sector and see how many bridges are between 5 and 9. So we have 4, 6, 7. No, not 4. We have 6, 7. So we have two bridges here at the left side, and at the right side we have 6 and 8. also two bridges. So this cell is stable, right? So that's it. So it's actually a matter of implementation. We we want to we want to pass through every cell, and then with two pointers, we'll see the previous sector and then see the sector after us, and then count the number of bridges intersecting this cell. Okay, let's implement that and see how could we make it. So take an and then we'll make a vector that stores um, the sectors. So it will be an array of vectors, and for each vector, for each view of I, it will store the number, it will store the actual bridges of sector number I. Okay, and then we take the number of bridges, which is k. And then for each k, we'll take some bridge, and then v of I. So sector I, I'll add to it bridge x. Okay. So now we took the input, and bridges are not sorted, right? Okay, so we want to sort the bridge first to make things easier. So because now we have mm, yes. Actually, I said something wrong here. So we are not we are checking every two consecutive bridges, but they must be sorted, right? So I shouldn't check 2 and 9. So I should check only 5 and 9, right? So each two consecutive bridges. So I should sort these bridges. Okay. So I'll make this check after sorting each view of I. That's it. I thought they are sorted, but okay.
Ahmad, you're not getting the input
I'm not getting the input what?
X. Where are you getting that X?
Yes, yes. Okay, sorry. So I'm getting X now. Okay, so now I want to loop over every cell. Okay, so I'll first loop through every sector. So int I equals to 0 is more than I plus plus. I'm now at sector number I. Okay, so before jumping into cells, I want to have two pointers pointing to the previous sector and to the sector after me. Okay, so let's say int prev and int after. So previous will be equals to I minus 1, right? After will be equals to I plus 1. But if I equals to 0, then I minus 1 would be negative 1. And if I equals to n minus 1, then I plus 1 will be n, which is out of bounds. So to solve this problem, for after, we'll mod I plus 1 with n. Because if it reaches n, then n mod n will be 0, so it will turn again to 0, okay? Because n is beside 0, so 7 is beside 1. At our case, 6 is beside 0. And for previous, mod won't work here, so we'll just make a check here. So if not I, so if it's 0, then previous equals to n minus 1. Okay, so if you are at I equals to 0, then the previous sector will be n minus 1, okay, the last one. So now we have previous and after. We will loop through every cell. So for int I equals to 1, I smaller than size I plus plus. Okay. So now we want to know how to check for the number of bridges between exactly between v of I. Let's this cannot be I, it should be j. So we want to know the number of bridges between exactly v of I of j and v of I of j minus 1, right? So this is the current cell. And we want to check the number of bridges between these bridges in previous and in after. Okay, let's define some variables here. So let's say int left. So let's say int left equals to the number of bridges at our left sector, and int right equals to the number of bridges at our right sector. Okay. Let's see. I'm just wondering if there are other variables I would like to define here. So C left and then right. Yes, so yeah, okay. So to get the number of bridges at our left side, we have two functions here in C++ called lower bound and upper bound. So these are actually just binary search, okay? So if you lower bound gets lower bound of x gets the smallest value greater than or equals to x in array, okay? So lower bound of r of array of x returns the smallest value greater than or equals to x in array. That's it. So instead of binary search at exactly x, it binary search at the smallest value greater than or equals to x. And for upper bound, it returns, it's the same thing, but not or equal. Okay, so it returns the smallest value greater than x in array. Okay, so at our case, we want to use upper bound. So we want to get the index of the first smallest value greater than. Okay, so now I know that we want to make 4 variables. Okay, I get it now. So let's say left is the index of the. So let's say left is the number of the bridge I'm standing at in the left side. Okay, so left will be equal v of I of j minus 1. Right will be equals to v of I of j. So left is the left bridge, right is the right bridge. Okay, so I want to use upper bound for the previous sector and the after sector and get the smallest value of the smallest value of a bridge after right, and then get the smallest value of a bridge after left, and then subtract them. So after that, we'll get the number of bridges between them. Let's take an example here. So we are now standing at some cell which is between 3 and 6, for example. Okay, and for the previous and after, we have some big array here which is 1, 3, 4, 5, 6, 10, for example. And for the after, we have 3, 4, 11, for example. Okay, and note that they are sorted. So to count the number of bridges between 3 and 6 in the previous and after, so I'll store it at up and down. Okay, so up will be the previous, down will be down. Down will be the after. Okay. So let's check at the previous array. So I want to count the number of bridges between 3 and 6, and so I will use upper bound on 6 and 3. So I'll use upper bound on 6 and get the number of values greater than 6, which is number of values exactly greater than 6 is 1, right? So upper bound actually don't return the number of values, it returns the index of it, okay? So here, let's say the index of 10 here is 5, and then I'll get the number, the index of the first smallest value greater than 3, which is 5 here, and the index of it will be 3, right? Then I'll subtract 5 from 3, which is 2, but then I get 1. Uh, is there a problem here? Okay, I'll subtract this from this, and then subtract 1. So if I subtracted, oh, okay, let's check for the after array. So for 3 and 6, we have also, we'll get 11 and let's add 5 here. So we'll get 11, which is 5, and we will get 4, which is 2. Okay, so actually I will subtract 1. So I'll get the index at of this after right, it should be 11, which is 4. Okay. So it will be 4 minus 2, which is exactly 2. So I'm saying that I'm getting the upper bound of right, and then subtracted by upper bound of left. Okay, but here's an extra one. We want to handle this case. We're gonna handle it now. But let's say we will just store for now the values of the upper bridges and down bridges. Okay, so upper will be upper bound. So these are, so I'm giving an iterator to the first element in the array I'm searching at, and the last element in the array. Okay, so I'll say v of previous dot begin. This is an iterator to the first element, iterator to the last element dot end, and then I'm searching for an upper bound of right. I'll subtract this by upper bound of left. Okay, and then at down we'll do the same thing, but for the after. Okay, here down goes upper bound. Okay, after. Okay, that's it. So up should now store the number of bridges intersecting this cell at the previous array, and down should store the number of bridges intersecting this cell at the after array. But let's handle this case. Oh yes, so what I'm saying here this formula should always work, because we cannot have this this thing isn't possible. So we cannot have six. So we cannot have two bridges at the same edge. So we cannot have six here and six here. Okay. So this could be any other thing. And we don't have duplicates. We don't have any two bridges at the same point. We never. Okay. So now we get the upper bound, which is 7. It will be at 4, and then 4 minus 3, which is 5, will be 1. And we actually have only one bridge between them. And here we're getting the upper bound, which is 4 minus 2, which is here at 4. It will be 2, because we have 4 and 5 between 3 and 6. Okay, so this formula will always work without any case handling. Okay, that's it. That's how we calculate if that's how we calculate the number of bridges. And to add to the answer the number of unstable cells, we make answer equals to 0. And just we'll add 1 if this cell is unstable. So answer plus equals, if up is not equals to down, then we'll add 1. Okay, any questions here? I finished the solution now. Any questions about this solution? About any detail? Okay, and then I print answer, and that's it. Let's check. Hope there are no errors. Okay, no errors. Let's check last time. Okay, let's submit. Okay, accepted. Here is the solution link. I sent it in the chat. Let's jump to the next problem. I sent the link in the chat. Read this problem carefully, because it have a lot of details, or small details. Then take your time.